All right, so we are on worksheet 12 in the regular prob and stats packet, not the addendum one. So these are the things you need to be able to do for the quiz, okay? I can use the empirical rule to calculate probabilities and normally distributed data, and you will get to use the reference sheets. You have to be able to calculate a z-score, okay? Which you will get to use the reference sheet that has the formula. And you need to be able to know how to use the norm CDF button. All right. Again, reviewing what this meant. The most widely used continuous probability distribution is called the normal distribution. And it approaches but never touches the x-axis, and then the entirety of the area underneath is 1 or 100% probability. And it means the mean, median, and mode are all at the same place. I just wanted to show you this. This is the equation for the normal distribution curve. Would you like to try to put that into your calculator or have to? Okay. It has, yeah, it's crazy. All right, so the empirical rule is also called the 68, 95, 99.7 rule. Okay, so it's on your reference sheet. What you need to know is that the first, it's one standard deviation, then add another standard deviation. If you go to the left, you're taking away standard deviations. So this question said about how many students are more than 72 inches tall. So they figured out with this mean and standard deviation, and they said this half would be 50%. They took off these two, which is 34 and 13.5, and that left 2.5%. And because it says how many of the 880 students, so you would do 0.025 times 880. Can you do that real quick, guys? I want to know if they rounded. I don't think they did. I think that one came out nice. 0.025 times 880, did that come out exactly 22? Okay, so therefore about 22 students. The rounding can be an issue, and honestly, I don't want to make it an issue, so if you come up with something and you round or leave it a decimal, it'll be fine. What percent of the students were between 59.5 and 69.5? The 59.5 went down 3 standard deviations. 69.5 went up 1 standard deviation. So they added that 2.35, 13.5, 34, and 34 to get 83.85. All right, so this is one I think we can do quickly. It says sketch and label. It says the average monthly temperatures for a city for 1 year were normally distributed with a mean of 65 and a standard deviation of 5. So if we go 3 standard, oh nice, I can even do this. Subtract, subtract, subtract 5, add 5, add 5, add 5. And they want to know, sketch and label, what is the probability it lands between 50 and 70? So if we were to shade this, because it does ask on the quiz for you to sketch and shade one, you would want to say all of that. Okay. What is this from here to here, guys? 1 standard deviation each way is? Speak up, somebody. What percent? 68. Okay. 1 standard deviation each way, but then we have this area and this area we also need to include. And what does it say on your sheet for those? 13.5, and is it 2 point, what does your sheet say, 2.35?
Yeah.
So if we add that all up, we get 70, 80, 83.85. Okay. Now, if you did it in the calculator, you would get a slightly different answer, okay? And I will ask you, I will specify, but you will use, when it asks you to use empirical rule, I'm going to make sure that that's the answer you get. If you get a different answer because you use the calculator, it's not going to be right. The heights of 200 trees in a nursery are normally distributed with a mean of 120 and a standard deviation of 16. Again, I think they want us to use empirical rules, so we're going to do 120, 136. I don't know if I can subtract 16, would be 104. If I take away 16 from that, is it 88? I see an 88 down here somewhere. Okay, I think that's all we need. We could keep going this way. If we had another 16, we'd have 152 maybe. I'm not going to be picky because it just says approximately how many trees are more than 136. So what is above here? Well, the best way to figure that out is actually to figure out what was below there. Because what is this always called, guys? 50%, right? Half. So 50% was below and another 34. So 100% of the trees minus 50 and 34 leaves 16%, if I did that right. Okay. So 16% are above, but how many trees is that? What do we got to do? Times 200 trees will be 0.16 times 200, or 32 if I did that right in my head. 32 trees. Now it says what percent, so we don't have to do that extra step, are between 88 and 104. So it wants this little tiny piece. If this was the mean, this was 34, and then what is the next little section on your sheet say? 13.5. And that's all they wanted was a percent. So far, so good? All right. Then it talks about z-scores. We talked about z-scores. It is the number of standard deviations that a value is away from the mean. Okay? It is on your reference sheet. And we will use these particularly to compare two different values from two different sets of data, so we can say how far they are each away from the mean. Just a little review of finding a z-score. So to find the z-score, you would say 65 minus 50. So it's 15 units away from the mean. And then when you divide by the standard deviation of 10, it would be 1.5 standard deviations. Above the mean. I just want you to know what that. All right, this one actually gives us the z-score, so it wants us to work backwards. Negative 0.4 equals some value away from the mean over 5. So what would we do first? Multiply to get rid of the division. Is that negative 2, guys? So then if we add 40, we get 38. Let me think about that. 38 minus 40 would be negative 2. Divided by 5 would be negative 0.4. Yep, I was just checking it by pulling it back in. All right. So those are just using this formula forward and backward. Little extra review there. All right, so characteristics, again, one standard deviation or one z-score above, two z-scores above, and so on. So almost all of the data is between 3 standard deviations above and below or 3 z-scores. They're just comparing it to z-scores now. This is just using the norm on your calculator. This is underneath, this is on your notes, right? It's on your reference sheet, isn't it? This little box to remind you how to use this. It says, second distribution will find norm CDF. You put in the lower z-score and the upper z-score. If you're not using z-scores, then it's norm CDF, it's upper, lower, mean, and standard deviation. If you have a newer calculator, it will prompt you for all those things. Everybody good? I know we're reviewing, but like half of you are on your phone. This does not seem appropriate. On his last 20 airline trips, an employee had an average layover of 82 minutes with a standard deviation of 7.5 minutes. Find the number of layovers that were less than 75 minutes. Okay, if we're going to use the calculator, I'm not going to do what they did. They did z-scores, but we could do norm CDF. What would, if you want to know all of the flights or layovers less than 75 minutes, what's the lower limit? Yeah, we could put 0, right? So wouldn't that be the easiest way? You could figure out like 4 standard deviations below and use that number, but it has to have a layover 0 to 75, so that would include everything less than 75 minutes, where the average layover was 82 and the standard deviation was 7.5. I don't even have this pulled up, I don't think. Okay, you guys type that in quick. How do you find it again? Second vars. It is number 2. And we decided to do 0 to, was it 75, guys? With a mean of 85, 82, and a standard deviation of, thank you. All right. I got about 17.5%, but didn't it say of his flights or something? On his last 20 flights. So times 20 flights is like 3.5. Did somebody else get that? Okay, so we could go 3 or 4, but I would say about 4 flights. So let's write our work. We got 0.0, what did we get? We got 0.175. And then we multiplied by 20. About 4 flights. All right, that one was done for you, but that's how we did it. At a restaurant, the average time between when an order is placed and when the entree is served is about 12.5 minutes with a mean of 1.2. Whoops. The standard deviation of 1.2. Man, if I could read, it would just be amazing today. Out of 100 randomly served customers, how many will be served their entrees within 14 minutes of ordering? Now, if I started to do this, 12.5, and add 1.2, and add 1.2 again, would I hit 14 minutes, guys? Does it come out nicely on 14 minutes, one of our standard deviations? No. So that's how, in theory, you're supposed to know to use the norm CDF, I would tell you on a quiz. But how do we say within 14 minutes, what do we want to use for a lower limit? I would use 0, yep, because you can't get your food any faster than 0 minutes, right? 0 to 14 minutes with a mean of 12.5 and a standard deviation of 1.2. 0 to 14, I already forgot, 12.5. Oh, I did leave just enough room there. And 1.2. And I got 89%-ish out of 100, so it's not quite 89.5, so I would say about 89 customers. 0.894 times 100 customers is going to round to 89.4, or about 89 customers. Everybody good? All right. Mrs., I don't know the proper pronunciation, Kwan, a full professor at a community college, earns a salary of $48,600. The average salary for a full professor is $52,000 with a standard deviation of $3,600. About how many of the 45 full professors earn less than Mrs. Kwan? So we want earn less than this amount, right? So if we use norm CDF, got the M. $52. I'm just checking if it lands on a standard deviation. Minus 3,600. Ugh. I can't type. Yeah, it doesn't, so I'm not going to worry about it. Okay, norm CDF. Earn less than her. Well, that would be 0 up to hers with a mean of, average is mean, and standard deviation. Okay, so second vars 2. What was hers? 48,600? $52,000. And what was the standard deviation? 3,600? Okay. So I got about 17 or 0.17, did it say 4? 1724? Okay, and how many teachers are we talking about? 45 teachers. Okay. Yeah, I was just going to leave the whole thing. And multiply it by what? 45, guys? So about 8? Eight make less than her. It's professors. Okay. All right. One more, I think. Is this the last one? Nope, got a couple more. All right. During 1 October, the average water temperature in a pond was 53.2 with a standard deviation of 2.3. How many days was the temperature greater than 50? So if we're going to use norm CDF, how do we say greater than 50? lower has to be 50, and what do we want to put for the max? Yeah, we could probably put 100 degrees, or Hofbauer's default is like 999. Anything above 50, how many days were greater than 50 degrees with a mean of 53.2 and a standard deviation of 2.3? All right, someone type that for me and tell me. Somebody have it? Okay. Someone else get 0.918? Okay. How many days in October? Trick question, you got to know something. 31, yes? Halloween? 31 days, okay. So 0.918 times 31 days, around 28 days, somewhere. Okay. So most of the time it's still warmer than 50 according to this. I feel like Illinois, we never know, right? All right, the average age of the swimmers on a master swim team is normally distributed with a mean of 56 and a standard deviation of 4. Find each probability. Are these 4 greater than 56 and 4 less than 56? Any of these numbers? No, they don't fall nicely. So just use your norm CDF. This one is really nice because it gives us both the lower and the upper. It says 53 and 59 with a mean of 56 and a standard deviation of 4. Anybody have that one down yet? Anybody else get 0.547? All right, and then how would we do less than 53? Pretend that says norm. Less than 53. It's age of people, so 0 to 53 works for me. I doubt they could make the masters, or that it's a master swim team, meaning old people. Anyway, 0 to 53, 56, and 4. Got 0.22. Okay. That would round to 7, I guess, but. All right, any questions? All right, on worksheet 13, I am not going to cover this section. This is working backwards. We're going to skip this all. And let's do this bottom question, number 10, because it's kind of interesting. Price of rooms at hotels around an airport are normally distributed with a mean of 120 and a standard deviation of 20. So if we were to do this, and you don't have to draw this because it would be 120 and 20 going this way and 20 going this way. And do these numbers land nicely on those? 150 is not on there, right? So we want to say greater than 150. We're going to use, I'll write it out, norm CDF. And then how do we say greater than 150? And up, we could use whatever you think the maximum price of a hotel room would be. It just needs to be more than like 4 standard deviation, which is $80 above 120. So you could put 200 in and it would give you the same answer. I'm going to put 999, 120, and 20. Somebody have an answer? Only about what? Yeah, about 6.7% maybe. If we change it to a percent, 0.0668. All right, the cost of a room is between 110 and 130. You will notice down here, it's talking about this chunk in here. So it is not landing right on nice standard deviations. You can just go back and type those over the numbers if you did second enter. 110 to 130. I got 38.3%. Okay, so it was norm CDF. Now I am abbreviating. 110, 130, 120, and 20. So we used these two as the lower and upper. Room between 90 and 100. 90 and 100 is talking about down here, so it's going to be a much smaller area under there. I got 0.092, or about 9.2% of the rooms. If only the most expensive 10% are available, what is the least you will pay for a room? That's actually one of those work backwards problems, I think, so we're going to cross that one out. And I want to do one more question on, is this 11? No, that's not the one I want to do. I want to do cross out 11. You can cross out 12. This is what I want to talk about. All right. Like percentiles, z-scores can be used to compare the relative position of two values in two different data sets. So, a student scored 65 on a biology exam with a mean of 50 and a standard deviation of 10. Now, you could, in theory, figure out how many students scored below this to find a percentile. It says she also scored 30 on a literature exam with a mean of 25 and a standard deviation of 5. So you could figure out how many students scored percentile below her. Compare on the English, compare her scores on each test, assume that both are normally distributed. A better way to do this is just to figure out how far she was from the mean. So on the bio test, she had a z-score, or away from the mean, 65 minus 50, divided by 10 was the standard deviation. So she was 1.5 standard deviations above the mean, above the norm or the average, okay? On her English test, was it English? Literature test? What? This is biology. Sorry. That was biology. All right, and on her lit test, what did she score? Guys, how far was her z-score away there? Can you do that one? She scored a 30 when the average was 25. And the standard deviation was 5. What does that come out? 1. So she's 1 standard deviation above. So which one did she do better on? The biology test, because she's further above the mean, okay? She scored further above the average. Bio was better, further above the average. This is the same way you could compare, you know, your cousin's ACT score to your SAT score. All right, you are going to do worksheet 14AB. It is bookwork out of the pre-calc book, but it's already on those pages.